Hi. Hello, everyone, and welcome to the Global Dev Study 4th event, Fast API and Python practice for this wonderful Tuesday night. I'm Ahon, a product manager at Groups, and I am the moderator for today's event. In today's event, we are honored to have the creator of Fast API, Mr. Sebastian Ramerick, to share with us the live intro of Fast API. And you will learn how to build a JSON API with Fast API, including some of the best practice with default. Also, our speakers, Mr. Ruben M. Lerner, the author of Python Workout, he will share about some essential Python exercise and their solution to help attendees become a better Python developer. Before we get started, I would like to share with you on how to participate in today's event. There are a couple of times you can ask questions to our guest speakers, and you can do so via a web app called Slido. If you would like to ask questions, please scan the Slido QR code on the screen. Right, that's all for the announcement, and I'm gonna go over the guest introduction. Our first speaker, Ruben Lerner, he's a full-time Python trainer. He teaches courses at a lot of companies in United States, Europe, Israel, India, and China, as well as to the people all around the world via his online course. His most recent book is Python Workout, a collection of Python exercise with extensive explanation published by Manning. He's currently working on Pandas Workout, which will be published by Manning in late 2021. Ruben's free weekly Better Developers newsletter is read by more than 20,000 developers around the world. So if you are interested to learn more about Python and software engineering, please subscribe to his newsletter. Hello, Ruben. So if you are ready for this presentation, yeah, you can go ahead and start now.
Hope I'm ready. Excellent, Han. Thanks so much. Hi, everyone. Welcome to this session. It's really fun to be here with you. Well, with you virtually, but that's the best we've been doing over this last year and a half or so. As Han mentioned, I am a Python trainer, and one of the most important things you can do to train, to improve your skills in anything, including in programming and certainly including in Python, is to practice with lots of exercises. And so what I try to do in all of my courses is have lots and lots of practice exercises. And I think it's important for all of us to constantly be practicing and trying things so that we can improve our skills and make sure we really know what we're doing. So what I want to do now in the time here together is I want to show you a few different exercises, exercises that I enjoy using in my various classes. And I want to show you how we can use them to improve our skills and understand how things work in Python. And so I'm going to actually show you 3 different exercises. I think we will have time for those. And by the way, I definitely encourage you all to write in with questions. So what we're going to do here is exercise. And by the way, I should add, I'm doing this all live coding, typing into the Jupyter Notebook. If you want, you can follow along live-ish. It's about a minute or 2 minutes of delay between what I type and what is actually put up there. But if you go up to my GitHub, you'll see that the Forkwell session is there, and then you can follow along just refreshing it in GitHub, and that'll be there after the session is done as well. So don't worry if you miss it or you want to pay attention to other things meanwhile. So what I'm going to do is I'm going to show you 3 exercises. One of them is one of my favorites, is an XML creator. It's going to be pretty quick. Then we're going to do something that I call read n, and the third one is I'm going to do something that I call once per minute. And I'm going to go through all 3 of these with you, and I'm going to both sort of pose the question, and I'm going to show you how we can answer it and how answering it can sort of get us thinking in new, different, better ways about what we're doing in Python and how it's working. So the first thing is, let's talk about an XML creator. So what I want to do, well, think of it this way. I remember back in the days before XML. Yes, I'm that old. And it was maddening that if we wanted to have data exchanged or just stored in various ways, it was really problematic to do that because there was no one single standard. And so XML came out, everyone said, wow, this is amazing, until, as anyone who has worked with XML knows, we discovered it was less amazing than perhaps we had hoped and we had thought. That said, XML is still used extensively. And what I want to do is so the problem is, or the exercise is, write a function XML that will take several types of arguments. and it'll take a tag name. That'll be that's mandatory. And it'll take text, and that'll be optional. And then it'll take optional key word arguments that will be used as the attributes. And attributes, in case, by the way, I'm assuming you have some familiarity with XML. If not, this is a good time to learn, right? And the basic idea is that the function should return a string containing the XML. So just as an example, if I were to say here, let's do it this way. If I were to say here XML of, and we'll say here tag name, or let's tag name and text, and then A equals 1, B equals 2, C equals 3, then what we would get back is a string, and we would see here, let's just do it this way. We would get back something that looks like, it would say here, like tag name, because we got to have the opening tag and the closing tag. And then we have the text in the middle there. And then the attributes are these key value pairs that appear inside of the opening tag. So that's the basic idea, that we would get back a string containing all of that. Okay, so how are we going to do this? Well, the best way to do programming in general, in my opinion, is to start small and little by little by little get to your goal. If you try to do everything at once, it's just going to be a real problem. So the first thing I'm going to do is I'm going to define my function, def of XML. And I'm going to say, well, let's just assume we only want to get the tag name. So I'm going to say here XML, and we'll call it even tag name. What can I do? How can I return a string? Well, I'm going to have to return a string, and I really like using F strings because they are nicely and formatted. And so after I return the F string, now I can say, well, let's do tag name. Yeah, but I don't just want the tag name. So we'll say like opening tag and closing tag. Oh, forgot the slash there. And look at that. Now if I say XML of my tag, let's call it, look at what I get back. I get back a string with the opening tag and a closing tag. Fantastic. So we're already part of the way through there. We haven't solved all the problem, but we've gotten part of the way through there. But now we are going to cause some trouble because that second argument is optional. That second argument of text, which we want to be able to use. Well, how are we going to do that? Well, the good news is that we can just do it this way. I can just put text in there, right? And once again, the F string allows me to have Python expressions inside the curly braces. So if I now say my, XML of my tag and let's say my text, that works perfectly well. The only problem is that if I go back to the one argument version, boom, it's not going to work. Why is it not going to work? Because the way that I define the function, both of these arguments are mandatory. Now, there are a few different ways that I could play this. And one common thing that people think they want to do is they think they want to use splat args here. That is to say, a special kind of parameter that gets all the positional arguments that no other parameter got. And then you can say, well, is it length of 1 or length of 2? And then based on that, we can decide, is it tag name and text, or is it just tag name? But I really don't like to do that. I much prefer, if I can, to use splat args only when I'm going to want to run like a loop over each of those things. I'm going to want to use them in something that's the same. To start pulling things out of splat args with a square bracket 0, square brackets 1, I'm just not a big fan of that. So instead, what I'm going to do is I'm going to give text a default value. I'm going to make that default value an empty string. And now what's going to happen is if I call it with one argument, well, what's going to happen? I call XML with one argument. Python says, wait, you need to have provided 2 arguments. But wait, that's okay because I can, since you only provided 1, I'm just going to provide this default value of an empty string for text. And so now what I can do is I can even say, print of XML of my tag. I can do here print XML of my tag and my text. Spelled incorrectly, of course. I can even say print XML of, and we can say like A, and then XML of B, and XML of C, hello. And that'll work just fine as well. Now, this last example here, it might look sort of recursive to you, but it's not. Recursion is when a function calls itself. Here, I'm calling XML 3 times. Well, what's happening here? Well, I'm calling XML once with A and O, whatever we get back from here. Then we have to call the second one. So we call XML of B and whatever we get back from there. Then finally, we call XML of C and hello. We get back a string. That string is the second argument to XML here. And the string we get back here is the second string for the second argument for XML here. And so what we see is it actually works the way we'd expect. A is on the outside. B is in the middle, and C is on the inside. And then hello is right there in the middle. So this is all great and everything, but, I said we also need to be able to get keyword arguments. And so far, or any keyword arguments, and so far we just have tag name and text. So how am I going to do that? Well, if I don't know what names and values I'm going to get, here I should use double splat KWArgs. And again, this is for capturing all of the key value pairs, all of the keyword arguments that were passed to the function that are not associated with any other parameter. So now what? Well, I know that I'm going to get key and value pairs, right? Key value, key value, key value. So what I can do is I can say here's something like this: attributes equals empty string. And then I can say, well, for key value in KWArgs items. Wait a second. Items is a method that only works on dictionaries. Aha, that's true. But KWArgs, by definition, is going to be a dictionary. We know this can be a dictionary of all the key value pairs that were passed to us. And if there were no key value pairs passed to us, that's okay too, because then it'll be an empty dictionary. And then our loop will do 0 iterations and we'll just have attributes as an empty string. And sure enough, if now I say attributes here, and I'm going to say now attributes plus equal, and we'll do a little F string magic here, and I'll say here key equals value. I can even put double quotes there to be like extra correct and nice. And now it'll work just great. Well, it'll almost work great. You'll see in just a moment. If I now say print XML of, and we'll just say here my tag and my text, but now I'm going to say here like, X equals 100 and Y equals 200 and C equals 300. Look at this. My tag X is all kind of squished together. And that's because, well, Python is doing what we asked it to do, and it's squishing all these things here. And so if I use a space there, then we're guaranteed to have some space. And look at that. Now we have my tag with all 3 of the attributes that we wanted that were passed as keyword arguments. We have the text in the middle here, and we have the tag on the outsides. So basically in 5 lines, 6 lines of Python, we've managed to implement all of XML. All right, maybe I'm exaggerating just a tiny bit, but yeah, we were able to implement that, which is pretty great. Now you could argue there's some better ways that I could do this too. I could use, I could use a comprehension instead, but we'll get to some other things that will be useful as well. So there you go. This is a nice, what I like, a demonstration of how we can use different kinds of parameters, how we can decide whether we want to use splat args or not, how we can decide whether we want to use double splat KWArgs or not. And it's got a mix of different data. And in the end, we're just returning a string. And it turns out to actually mirror and be close to stuff that we're familiar with from our day-to-day work. Okay, that was number 1. Number 2. All right, so exercise. This one I like to call read n. And so what I want to do is, let's see, describe it this way. When we iterate over a file object, nowadays, by the way, we say a file-like object. Why? Because back in Python 2 days, we actually had a file object that we could use. When we would call open, we would get back a file object. Nowadays, there are many objects that actually implement that API. So yes, there are the file objects, and open now returns something much more complex, depending on whether it's textual or binary. But basically, we'll get back something. But we also have things like string IO, and you also have a few other things that implement the file API. So nowadays they're called file-like objects, even though I don't think that really helps anyone to understand it if they are new to this. So we get, each iteration returns the next line in the file, right? When we reach the end of the file, the iterations stop. So that sounds pretty good, right? The thing is, what if the file we want to read from contains data that's structured in 2-line segments or 4-line segments? That is to say, the normal Python way of reading through files assumes that every line is a separate record. But there's no rule that says we have to do that. It could be that there are 2 lines for a record, or 5 lines for a record, or 10 lines for a record, or maybe we just want to pull out chunks of different sizes. So what I want to be able to do is read through this file one little bit at a time, but I want to determine what that bit is. I want to determine how many lines should be in each chunk, thus n. So I want to, the problem is to write a function, read n, that takes 2 arguments, right? And it's going to take, first of all, file name, right? The name of the file to read from. And it's also going to take n, pretty clever, how to call it n, and the function is called readN, the number of lines that we should get in each chunk. Now, the other thing I should note, 2 more things. So first of all, this should be, and we'll talk about this in a moment, this should be a generator function so that we can iterate over it. And also, when we reach the end of the file, we can return fewer than n lines, right? Sort of, the remainder, that's left. And basically, that's just because if the file does not, divide evenly into the number of lines that we asked for, we can still get a result. So how is something like this going to work? Well, first of all, what the heck do I mean by a generator function? Well, normally when we write a function, it returns a value, right? We're going to use the return statement. Indeed, we did that before with the XML exercise. But here, I'm looking to not get one value back. I'm looking to get a series of values back. First iteration, second iteration, third iteration, and so on, and so on, and so on. And so basically, I can't use return in such a function because return is going to return once. Rather, I'm going to use yield. And once Python notices yield inside of a function definition, it says, aha, this is not a regular function. This is a generator function. This is a function that when we run it will give us back a generator object. That is to say, something that knows how to behave inside of a for loop. And then we can iterate over that. And what will happen is with each iteration, each time the for loop asks for the next thing, the next thing, the next thing, then the function is going to run up to and including the next yield. And then again, up to including the next yield, up to including the next yield. And only when we exit from the function do the iterations actually stop. So what I can do here is I can say def readN, file name n. And if I want to do this in the simplest, dumbest possible way, again, that's not a bad approach. I can say for one line in open file name, yield one line. Now, if I do this, have I really improved things any? No. Have I really implemented what I wanted? No, but we are one step closer. So I can say for one chunk in readN of, and here I'm going to use my favorite punching bag, Etsy password and 5. Why is it all the way over there? I don't know. Print one chunk. And what do I get? That's right. I get the file one line at a time. Not only that, but because reading from the file gives me back one line at a time, including the new line. So I'm getting one empty line here from the lines and one empty line here from print, because print always adds a new line unless you tell it otherwise. But we'll deal with that in a little bit. So this is not that useful, but it's starting to take shape. It's starting to take shape. So what can I do? Instead, what I can do is I can say something like this. I can say with open file name as f. So now I'm going to open the file. And then, now why would I want to do that instead? So now I can do this. I can say here, output equals f.readLine. Now, normally I don't actually use the readLine method very much. ReadLine, as its name seems to indicate, basically says, I want to get the next line in the file. It always returns a string. Always, always, always. If we're still in the file, then we will get back the next line, which is a string. But if we're at the end of the file, we're going to get back an empty string. So readLine will never give us an error, even if we're at the end of the file. So now I've got output. And now I can do this. Now I can say if output, meaning if it's not an empty string, because remember, inside of a Boolean context in Python, everything is considered true except for false, none, 0, and empty things. So empty string in an if is considered false. Empty list, empty dictionary, empty tuple, empty set, all considered false in that sort of what I call a Boolean context. So if it's output, then I'll say yield output. Else, what we're going to do? We're going to just say break. Break. Wait a second. Break for what? Oh, yeah. I'm only returning one line so far. I'd better put in a while loop. So let's do this. Let's say while true. Now, while true gives people the heebie-jeebies. People are always so worried about what happens if they use while true, because, oh my God, it's an infinite loop. Now, here's a little like professional tip for you. Infinite loops are fantastic if you charge your clients by the hour. But more seriously, an infinite loop is actually not so terrible if we know that we're going to be able to escape. And we have here an escape mode. So while true, oh, I should get actually the output. I should get that here. Otherwise, we are going to have an infinite loop, and that'll be kind of bad. So what are we going to do? We are opening the file. We're entering our while loop, and we're going to keep getting a line, one line at a time. By the way, what would be wrong? Like, this sort of assumes that we don't want to read the entire file at once, right? And in fact, the default behavior in Python assumes we don't want to read the whole file at once. What would be wrong with doing that? Well, what if you try to read from a 2 terabyte or 10 terabyte file? The odds are pretty good that you do not have 2 or 10 terabytes of RAM in your computer. And so if you try to read the whole thing at once, Python will gladly try. It'll read all the data into memory. And if it still has room, which it probably won't, it'll try to create a string based on that. Not so good. Read line and all these iterations and everything we're trying to do here assumes we don't have enough room in memory for all the files we want to read, but we do have room for the individual lines. So by reading a line or multiple lines, I'm going to save on memory and allow myself to work with any size file, not just small files. Okay, so we're going to open the file. We are going to, while true, we're going to get a read line. And with each iteration, we're going to get one and either output it or break. And then, is that working? It is working great, except for the end stuff. Yeah. So how can we now get n lines at a time? Well, one way to do it is to say output equals an empty string for I in range n, output plus equals f.readline. That will actually work. And look at this. Now I'm going to get 5 lines and 5 lines and 5 lines and 5 lines. It's actually working. And if I change that number to be, let's say, 7, that will work as well. I'm getting 7 lines and 7 lines and 7 lines. It really did work. Because when I call readN, I'm not actually getting back the output from the function. Rather, I'm getting back that generator object that the for loop turns to. It says, hey, do you know how to operate inside of a for loop? readN says, yes, I do. Or the generator returned from readN says, yes, I do. And so the for loop says, give me your next, give me your next, give me your next. And with each iteration, each time it says next, this function runs up to and including the next yield. Then it falls asleep. And then it waits for us to wake it up and ask for the next thing. So it's a very nice sort of combination of things that we're doing here. This is great. But, I think we can do better here. Because yes, I could use a for loop here. And as I like to say, unfortunately, it works, right? It will give us the answer that we want. However, I think it would be better for us to use a comprehension here. I think what I can do is I can say output equals, and we're going to say empty string join of f readline for I in range n. Now, let's first see that this works, and then I'll explain what's going on. And sure enough, it does seem to be working. We are getting now 7 lines at a time, so that's fantastic. But what the heck is this? So if you're not familiar with comprehensions, they are fantastic. They're just a great thing in Python that allows us to, what do I want to say? Allows us to take one iterable, one thing that over which we can run a for loop, and transform it into another thing over which we can run a for loop. And here we're doing that with lists. So we're actually creating a new list each time, a new list of n lines, which is going to be f read lines. So basically what we're doing is we're creating a list of n elements, and then we're joining that together with empty string and sticking that into input. And this is great. This is great. It's a more sort of, I would say, idiomatic way to do it in Python. So are there any problems here? Is there a problem? Not really. But we can make it better. Because it turns out that we are creating a list here, and we could just drop those square brackets, and then we're using, this is a generator expression. In other words, I've now created a generator function, which returns a generator, meaning that's iterable, and I'm using inside of it a generator function. And so this will actually still work. It works just fine. But this is considered a little more modern, a little cleaner. As I like to say, for something small, it doesn't matter. But for something big, it matters a lot. So using this sort of generator expression inside of join or inside another function call is really a good thing and a good way to go. Okay, so now we have our readN, and we can indeed get as many or as few lines as we want from a file, chunking it as we need. Okay, next up. Now we're going to do some fun stuff with decorators. And so now we're going to say an exercise, and I'm going to call this once per minute. And so what's the deal here? Well, normally we want to run functions, right? Or we want to be able to run a function on our own schedule whenever it's good for us. But some functions are real resource hogs, and we don't want to run them too often. So what I want to do, the exercise is to write a function that ensure, or I'm sorry, not a function, write a decorator. We're going to talk about decorators in a moment. Write a decorator that ensures a function can only be run once per minute or once in any 60-second period. So where do we even go for this? What do we do with this? Well, let's first create some functions that we can throw at this. So I'm going to say here def add of A and B, return A plus B. And I can say def mul of A and B, return A plus B. Okay, now we have our functions. Fantastic. But how am I going to decorate them? Well, what is a decorator? A decorator is basically a construct in Python that allows us to almost hijack a function when it is being defined and when it is being run. So we have two chances to do something. We can do something when the function is being defined, and then we can do something when the function is being run each time. And what's happening is a big switcheroo, that we are defining our decorator, and the decorator is actually going to be, as you'll see in a moment, a function inside of a function. And the inner function, or I should say the outer function, is going to be run once. And then it's going to return our inner function, which will replace our original function. Sounds a little complex. Let's see what we can do with it. So I'm going to say here, let's define it up top here. I'm going to say def once per minute. And this is going to take func. It's going to take, so decorator functions take, the function as an argument. And then I'm going to say def wrapper. It's pretty typical to say def wrapper. And now def wrapper, let's just leave that empty for now. We'll get to that in a moment. And then what I'm going to do is I'm going to say here, value equals func. So I'm going to call that function. Now you might say, wait a second, how do I have access to func here inside the inner function? Isn't func a parameter of once per minute? Yes, it is. Aren't parameters local variables? Yes, they are. But here's the cool thing. Python scoping allows us to find if we have an inner function, if we have an inner function, outer function, the inner function has access to the outer function's variables, local variables. So yeah, there's no problem with this. This is thanks to the LEGB rule. It stands for local enclosing global built-in. So thanks to this, basically when I ask for func, Python says, well, is func a local variable? No, it's not. Is it an enclosing variable? Meaning, is it a local variable in the enclosing function? The answer is yes. So we grab the value and it is fine. And then what I can do is I can say return value. And then I'm going to say return wrapper. So what's going to happen is when I decorate add and when I decorate mul, when we decorate the function, it's going to run once per minute, and that's going to return our wrapper. And the wrapper is then going to replace our original function. So I can now say once per minute. And then I can say here, once per minute. Now, of course, I don't have any of the functionality we asked for. And in fact, it's going to break in the biggest possible way in just a moment. And I can say print add of 2 and 3. Say print mul of 5 and 6. And say print add of 10 and 4. And print mul of 8 and 15. And sure enough, we get an error. I did say that. It says wrapper takes 0 positional arguments, but 2 were given. Huh? What does wrapper have to do with this? Let's think about what's happening. When we decorate a function, what this means is the same as add equals once per minute of add. Meaning, let's take the function we just defined. It actually would have to be at the bottom there. Take the function we just defined, run it on add once per minute, and then assign back to add whatever we got back for once per minute. So that's fine, sort of. It means that when we call add now, we're not really calling add, we're calling wrapper. And I called add with 2 and 3. And it says, wait a minute, wrapper doesn't take any arguments. Fine, so we'll deal with that. We'll say flat args here, right? Our positional arguments, we're going to take all the positional arguments that no one else wants. And now I run it and I get again a type error, but it's a different type error. Now it's saying, hey, dummy. It might be a little more polite than that. It's saying, hey, add expects to get 2 arguments. And here's where it's a little head twisting. Basically, when I call func here, that is the original add, not the one that we replaced it with. And I need to pass it arguments. How am I going to do that? Well, I've gotten the arguments that were passed here in splat-args, so I'm just going to pass those along in splat-args. And now, actually, look at that. It's all working great. Well, except for the once per minute part. So what can we do here, and how can we do it? Well, here's the thing. I do want to stop it from being run more than once per minute. So I'm going to need to check the time. So let's check it. I'm going to say here, import time. I know there are people who like to use perf counter. I'm just going to use time.time. I know people hate it and everything, but it's like easier to deal with for right now. So what I'm going to do is I'm going to say, right, current time equals time.time. And then, well, what? What can I do now? Well, I'm going to check it against, I want to check it against the previous time we ran the function. But you know, functions only have access to their own variables, right? Aha, but what if I store it in the outer function? What if I say, last ran at equals 0? And then what I can do is I can say here, current time equals time.time. And then I can say if current time minus last ran at is less than 60, we'll do arrays, and let's create our own little custom exception here. We'll say class, run to often error. So I can say, if it's been less than 60 seconds, we'll say arrays of run to often error. There we go, often error. Right, wait longer before running. And I'll actually say which function it is we're running. Func.thunder name. That gives us the function name that we're running. So if the current time minus last ran is less than 60, then we'll raise that error. Otherwise, you know what I'm going to do? That's right. I'm going to otherwise say last ran at equals current time. Sounds pretty good, right? Oh, of course it's not. You've seen me already. We got one of my favorite errors in Python, unbound local error. And what unbound local error does is it says, listen, you are trying to use a local variable before you define it. And you might think, well, how is that possible? And the answer is pretty clearly here in line 12. We are trying to, we only define last ran at in line 12, but we're using last ran at in line 10. You might think, but last ran at is a variable in the outer function. Why would it mistake it for one in the inner function? The answer is very simple. If you don't specify otherwise, then when you define a variable inside of a function, it is a local variable. You must be explicit about it. So let's be explicit. I'm going to say here, non-local last ran at. Now when I do that, it means don't try to store last ran at as a local variable. Rather, use it as as a local variable in the outer function. And when I do this, watch this. We get 5, we get 11, and then run to often error. It worked. It worked. So basically, I can now decorate any function I want with once per minute, and it'll work fine and transparently normally. But if it doesn't, if we've spent less than 60 minutes waiting, that's not a problem. Also notice I called 2 different functions here, add and mul. And I got add, I got mul. It's only when we tried to add a second time that we got the error. And people are often surprised by this. They think that I ran add, then I ran mul right away, so mul should give me trouble. No, not necessarily. Right? Mul is a different instance of wrapper, hard as that is to understand maybe. Right? It basically, I called once per minute twice, and each time gave me a different version of wrapper. I just want to show you one more thing we can do here. What if I want to make this even jazzier and fancier? Because I don't want to just be able to call once per minute. I want to be able to call once per n, where n is any number of seconds. So if I say once per n, let's say 3, and this will be once per n 0, like, allow it. Well, actually, it's kind of dumb. 1. So now what's going to happen? Well, this is not going to work. It's not going to work the way I did this here because the decorator taking an argument complicates things. What happened to the decorator it's being called on the function? Yeah, that's going to be a problem. So tell you what, if I want my decorator to take an argument, I have to use 3 functions. The outer one gets the argument. The middle one gets the function, and the inner one, that's where we do the the hard work, I guess, called each time we invoke the original function name. So now what? How am I going to do this? Well, I'm going to say def once per minute of, and I'm going to say here n. Right, that's going to be b. I wanted n. There we go. And now I'm going to say def middle of func. And now I'm just going to turn all this indent a little bit. And once I do that, then I'm going to say here, return middle. So I've taken a 2-phase inner function, right? Inner and outer function. And now I have 3 parts to it. The outer function, the middle function, and the wrapper, the inner function there. And now if I try running it, well, it's actually not going to work well. Why? Because I didn't change. Wait, what's it saying here? Name error. Oh, once per n is not defined. That will also do it. I have to change the name here. I was expecting something else. I actually need to say not last ran at -60, but I want to say here last ran at -n. Now let's do it. So 5 and 11 and run too often error. But if I go back and I make these both 0, now they'll run all the way through. So now we have this handy way of using decorators to ensure that our functions only run once per number of times. So I've reached the end of what I wanted to show you. I know there'll be some time for questions a little later, but basically I hope that you see that by being posed questions and having to solve them, it's a great way to sort of exercise, exercise not just Python, but sort of your mind and doing new things. This is why I keep telling people exercises, exercise, exercise. We do it for our bodies, we should do it for our minds, and we should do it. It's like if you learn a foreign language, and I guess since I'm speaking to you folks, English is a foreign language, right? But when you learn a foreign language, you have to keep practicing it all the time to keep it fresh. And Python is a language. It's a programming language, but it is a language. And so constantly challenging yourself with new things will help to keep it fresh, help to keep you understanding it, and allow you to improve the way that you do your work now in the future. So I'll be back later, I guess, with Q&A. If you want to see this, just to remind you, you can go to my GitHub, and this whole Jupyter Notebook is mirrored there. It'll be there for a long time. And I'd be happy to hear from any and all of you, both now and later on. So thanks a lot, and I guess I will see you folks later in the Q&A.
Right. Thank you, everyone, for the insightful sharing. So if any attendees will have any questions to ask Ruan, please scan the QR code and ask the question to him. Now we'll be showcasing a video about Fogwell, and then we will have a rest time until 8:20. Please enjoy.
皆さんどうもこんにちは。フォークエルで技術コミュニティの支援をしている重本と申します。今日は皆さんに自由なエンジニア、不自由なエンジニアというお話をしたいと思います。よろしくお願いいたします。では早速、不自由なエンジニアの特徴から見ていきましょう。私たちから見た不自由なエンジニアの特徴はズバリ、市場の評価と社内の評価が釣り合っていないとき、こういう時なかなか不自由ですよね。例えば、社内評価が市場評価に対して低ければ、なかなか自分のやりたい仕事が回ってこなかったり、待遇が良くならなかったりと。あるいは、社内評価に対して市場評価が低くても、これまた不自由で気がついたら他の開発環境でできないスキルセットになってしまっていて、気がつけば胃の中の開発状態、他の開発環境に行こうと思ってももう身動き取れないみたいな、そんな状態になってしまっています。ではこの自由なエンジニアどうかというと、この市場評価社内評価が非常に高い位置で釣り合っているんですね。市場社内ともに評価されているというわけなんですけれども、この差がなんで生まれてしまうのかという話です。 これズバリですね、市場の評価ってめちゃくちゃ見えにくくなってるので、どうしても社内評価に偏りがちになってしまうという話なんですけれども、そうは言っても自由なエンジニアは自分の市場評価をしっかり意識してギャップを埋めてはるんですね。例えば社内評価が低い人は自分の実力をもっと会社にアピールしていっていたりとか、市場から見えない自分の課題、コミュニケーションだったりチームワークの課題、そういったものを改善していっています。逆に市場評価が低ければ、もっと他の開発環境でできるスキルを磨いていってアピールしていくと。そうすることで市場の評価、社内評価が釣り合って、自分のやりたい仕事、そしていいお給料をもらえて自由な働き方に近づくことができるという、そういうわけなんですけれども、じゃあこの市場評価どないして確かめたらええねんっていう話なんですけれども、これはですね、勉強会、懇親会っていうのがすごくいいと思っています。なので普段も勉強会を開催したりスポンサー活動をやっているわけなんですけれども、この1年2年なかなか厳しかったと思います。社外との出会いが極端に減ってしまったと。じゃあここでどないしたらいいかというと、ここでぜひですね、スカウトをお勧めしたいと思っております。そこで実際エンジニアの方にスカウトについて聞いてみたんですけれども、スカウト嬉しいけれども大量のスカウトが来て面倒、そして開けても中身大概一緒で、会いに行ってもスカウトは言うての志望理由を聞かれたとか、面接確約言うての書類選考で落とされたとか、他にもこんな例がいくらでも出てきたんですね。今画面の奥でもうなずいてあると思うんですけれども、じゃあなんでこんなことなってまうねんということで、次人事の方に聞いてみました。すると、
スキルもわからないのに週に100通の携帯があるから検査結果に一回送信して返信は来てから考えてるんですよ。もう僕にそんなこと言い話してくださいよ。
そう言わはるんですけれども、この状態が一番不自由やなと思いまして作りました。エンジニアも人事も自由になれるスカウトサービス、フォークエルスカウトです。特徴主に3つございます。まず第一に一括送信機能ございません。なのでスパムメールは届きません。第2に簡単にポートフォリオから自分の強みを伝えることができます。第3、スカウトメールを見たら自分のどこが評価されているのか分かるようになっています。というわけで、こういった企業の皆様があなたのことを待っております。ぜひ、皆さんにご登録いただければと思っております。
everyone, welcome back to the Global Dev Study event. So I would like to introduce Sebastian Ramirez to you all. He's the creator of Fast API, Typer, and other open source tools. Fast API was included in the last official Python developer survey of 2020, and it was ranked as the third most used Python web framework, and by different metrics. Fast API could be considered the Python web framework with the highest growth rate. Currently, Sebastian is a staff software engineer at Forethought, and he's dedicating a high percentage of his working time to Fast API, Typer, and the other open source project. I will pass it over to Sebastian. So if you are ready, please go ahead.
Thank you very much. Hello, everyone. It's a pleasure to be here with you all. We're going to see a live introduction into Fast API. That provides high performance, it's easy to learn, it's fast to code, and the end result is ready for production. So, as Juan was saying, I am Sebastian Ramirez. I am from Colombia in South America, but I am living in Berlin, in Germany. You can find me on GitHub, on LinkedIn, and on Twitter. And I'm currently working at Forethought as a staff software engineer. And I'm also doing some external consulting with other teams, while at the same time I'm working a lot on Fast API, Typer, and a bunch of other open source projects. And as Juan was saying, Fast API is a web API framework. It currently has 32,000 GitHub stars. It has been growing about 1,000 stars per month, so people have been liking it. It's currently used by Microsoft, Uber, Netflix, and a bunch of other companies. And the performance that you can get is in the top rank in terms of concurrency, is in the top rank of what you can get for Python. So that is comparable to Golang or Node.js. And it's currently the third most used Python web framework. But what we are going to do is that we are going to explore Fast API live in the editor coding. So I'm going to share with you my editor. And this is what we are going to do. I have this directory, Fast API Live. Here's where we are coding. And I have this virtual environment here. So I'm going to load the virtual environment. I'm going to activate it. And now we're inside of the virtual environment. And now I can install Fast API with pip, install Fast API. We're just going to install Fast API. Works, and now we are going to install Uvicorn, which is the server that runs the application that we will build with Fast API. So pip install Uvicorn, and we're gonna install with Uvicorn in quotes and put in this brackets standard so that it includes like all the high performance stuff and the conveniences for Uvicorn. Now execute this and we get Uvicorn installed here. You probably will have a different way to install the packages. You might have a requirements.txt file, or you might use Poetry or something different. But for this example, this is enough for our cases. So now I have this directory here. This is the virtual environment where we installed everything. And we're going to use this file, main.py. This is all what we're going to do. So I'm going to close this bar on the side. And this is how Fast API works. So from Fast API, we import the Fast API class, and now we can create an object app, which will be an instance of this Fast API class. I am currently using GitHub Copilot, so that's why this auto-completes automatically. And now with this, I can create a new path operation or a new endpoint with a decorator app.get. And now I'm passing this string as a parameter to this decorator. And actually, let's finish that. Define recruit. For now, let's just say pass. This is what we are saying. We are saying this is going to handle HTTP GET operations or HTTP GET methods. And whatever goes to the route slash, like the root level root, is going to be handled by this function. And what we are going to do is that we are just going to return a simple message saying, hello world. Actually, let's say just message, and this is going to be hello world. Hello world. Yes, nice. This works. This is already a completely valid FastAPI application. This is already, this is already a FastAPI application. And now we're going to run it with Uvicorn. So we run Uvicorn, and then we pass the name of the Python module that we want to use. In this case, it's main, because the file is main. And then we put a colon, and then we say the name of the object that is the application that we are going to run, main app. This here, this will be the equivalent of saying from main import app. This is the equivalent here for Uvicorn, is the equivalent for this. So we are telling Uvicorn, hey, use this app object. This is the app that I want you to run. That's what it means. And now we're going to call this, and we're actually going to pass this option reload. We're going to call that. And that way, we're going to start the server. So this server is starting here. And now I can go and open it. And we can see that we already received the message, hello world. And this is the JSON response that I'm receiving. If I have an extension to show me JSON with formatting, but if I see the raw response, it's just like pure JSON text that we receive. And you can see that we are receiving the same contents that we are sending here. So this is already a valid FastAPI application. Now, what we are going to do is that we are going to add a little more stuff to this. So we are going to say that we want to get items in this application. So we're going to say, app.get. We're going to say items, and we want to get an item with an ID. Item ID. And now we want to create a function to read these items. I'm not going to take the suggestion from GitHub Copilot because we don't want to do all that. We want to say item ID is going to be a string. And now we're just going to return this dictionary saying, hey, this item ID that you are requesting is this one. That's it. That's enough. We save that. After saving the file, Uvicorn, because we are running Uvicorn with the reload option, is detecting that we changed the file and is reloading the process. So we can now reload here, and we can go to /items/full, for example. And if we go there, we can see that we are getting the responses. Item ID is this same path parameter full. So this is how this works. The path that we are using is /items/ and then we are passing this last thing. This is full. This is a path parameter, and we are declaring it here. And FastAPI is going to put it inside of the parameter or the argument for this function, item ID. And now inside of our function, we can use this item ID. Now, actually, let's do something. Let's say that the item ID is not going to be a string, but actually an integer. So this is going to be an integer. This is the standard Python syntax to declare that something is of type integer. We're saying item ID is an integer. And now this is reloaded. Now let's actually pass an integer here. We go to items 5. What do we get? We get the response. And as you can see, we're not getting, this is not a string that we are receiving. This is a JSON number. So FastAPI is doing data conversion automatically. We told it that this item ID should be as an integer, and it's giving us an actual integer instead of a string. We can confirm that by saying something like next ID will be item ID +1. Just a silly example. But if we reload this, we can see that item ID is 5 and next ID is 6. If this item ID was not an integer but a string, we will receive 51 or something like that. Great. What happens if we pass something that is not an actual integer? Let's say that we try again with full. If we do that, then FastAPI is going to protect our code from executing with something with invalid data. It's going to validate the data that it receives, and it's going to tell the client, so in this case it's ourselves, that there is a problem in the path of the request, specifically in the parameter item ID. And the problem is that the value is not a valid integer. So FastAPI is doing data conversion because we receive an actual integer just as we declare it. But it's also doing data validation because it's not letting the invalid data pass through, and is protecting our code from executing with invalid data. Now let's do something else. Let's say, so this item ID comes from the path parameter. Let's actually say that we want to have a query parameter here too. We want to say that Q is going to be a string, but we don't want Q to be required. So we are going to say that by default, Q is going to be none. And we save this, and now we're going to only return this item ID, and we're also going to return what is the Q parameter that we sent. Now we save this, and if we reload here, let's actually pass a valid item ID, like 5, and we see that Q is null. We said in our code, in the function, we say Q is of type string, and by default is false. Because it has a default value, then Q is not a required parameter. And the default value is none, and none in JSON is null. How do we pass this Q? So this Q is a query parameter. We can pass it here after a question mark. We can say Q is going to be equal hello. Let's just send that. If we send that, now what FastAPI is going to do is that it's going to read this query parameter here, and it's going to extract this value hello, and it's going to put it in this parameter Q. So we will have the Q inside of our code. Now, this is I think this is the fun part, the funnest part. If we go to /docs, FastAPI automatically generates this interactive API documentation for us. We can see that we declared a get here, and this is the get here. It's an HTTP get request, and it goes to /. So this one goes to /. If we click here on try it out, we can execute this request, this example request, and the user interface, the automatic interactive API user interface that is running here on the web, generated automatically for us. If we execute this, we are indeed, the browser is indeed communicating with our server here, and we're getting the response here with the content that we are actually sending from our server. Now let's actually see the other one. This one that goes to, it's a GET request that goes to /items/ and then we have this item ID query parameter. So, sorry, this is a path parameter. We can try it out, and we can see that the documentation already knows that item ID is a path parameter and it's of type integer. If we try to say like foo, for example, we try to execute it, the web user interface won't allow us to even try. So it's actually telling us, hey, you cannot just simply put foo. You have to put a number. So let's say we pass 5 and we execute it. We can see how is the URL for this. This is the URL. And the response is what we expected of having the item ID, and Q is by default null. What happens if we pass a Q here as hello? Then this Q is going to be sent like this. This is the query that the URL that we are using now, and with the query parameters, we have the query parameter Q is going to have the value hello. So now we are using this value hello inside of this. And because we are using standard Python type annotations, oops, I added an here. Because we are using standard Python type annotations, the editor is going to be able to help us write our code, and it's going to help us writing the code and making sure that we don't have bugs with type checks. For example, let's say that we say hello with capitals, hello. And we want to show the query value. We want this query parameter Q, we want to show it only in lowercase. So we can say, actually, I want it in Q.lower. So yeah, that will work. But if we see, this is actually giving us a little error with red squiggly lines. The editor is helping us, telling us, hey, lower is not a known member of none. So it will work if Q is a string always, but we say that by default is none. So this is actually maybe it could be none. We can actually be a little bit more explicit with this and saying that this is optional. And this optional, we have to import it from typing import optional. So it's imported here. This is the standard way in Python to declare that something is a string or none. So we are saying Q could be none. How do we fix this? Then we can say current Q is equal to Q, I guess. And if Q is none, then we can say current Q equals to an empty string, and then just put here Q is equal to current Q dot lower, or something like that. But now we fixed the problem that actually we should say we shouldn't put this here. We should put it below. If Q is no current Q is this, else we're going to say current Q is equal to Q. And now, because we have this variable created here, by this point, this else will only be executed if Q is not none. So Q will have to have a value. The editor is smart enough to know that in here, Q could be a string or it could be none. But inside of the else, it knows that Q has to be a string, because we already checked the other option. So it knows that current Q will be for sure a string. Now we can save this and we can try that and it's going to work. Actually, let's try the broken version first to see how it actually breaks. If we execute it like that, hello is put in lowercase, but if we don't send anything and we execute it, we get an error in our server. So the editor is preventing us from building code with errors. Now let's actually redo all that stuff that we have here. And now this should work properly. So Q has the empty string. A very much simpler way to do that would have been to just say that Q has a default value of an empty string. And to say that this is not optional anymore, this is always a string. Great. But that allowed us to see how the editor is actually helping us with these different types of values. So we get all the benefits from type annotations, from standard Python type annotations by using FastAPI, but at the same time, FastAPI is doing data conversion and data validation from these parameters. Now let's actually do something else. We want to create a post request. We want to receive data. So we are going to say, from Pydantic, import base model. FastAPI is built on top of two libraries. One is Pydantic, and the other is Starlet. Starlet does all the web stuff. Pydantic does all the data stuff. So now we're going to use Pydantic to create the type of data that we want to receive. So we are going to create a class item that inherits from base model. And this one is going to have a name, which is a string, a description, which is an optional string. So again, this is the standard way of declaring that something is a string or none. This is not something specific for Pydantic. This is just standard Python. And we also want to have a price, which is a float. Nice. Now we're going to create a new path operation here. This one is not going to be a get, but a post parameter, a post HTTP operation. So this is actually fine. We're going to say app.post items, and we are going to say create item. This actually works. We're going to say create item. We want this item is going to be an instance of the class item. Again, this is the standard way of declaring this in Python. This means that item will be an instance of the class item, and then we are just returning it. Now we can save it and we can reload the interactive documentation interface, and we can see that we have the three path operations that we declared, and they are all here. Now we have this post post operation here that goes to /items as we declare it. That goes to /items, and we can try it out, and we can see that it automatically knows that the type of data that we expect has a name that is a string. So we have a name that is a string, a description that is also a string. In this case, the description is optional and it could be none too. And we have a price, which is a float. So we have the price here. Let's actually use this. Let's say that the name that we want to use is sushi. The description is deliciousness, and the price is going to be 9. And we execute it. And now we are going to see that we receive the response with the same data that we sent, because that's what we are returning here. We can also say we want to return item name. This is item dot, and because we are using standard type annotations here, the editor knows what are the available methods and attributes of these objects. So we can say item dot name, and we get auto-completion for this. And we can save this, and now if we execute this again, we're going to receive the new message saying item name is, what is the item name that we sent? Sushi. Item name is sushi. Nice. Now, what happens if we send invalid data? Let's say price is supposed to be a float. What if instead of a float, we say 9? If we execute this, then again, FastAPI is going to do data validation for us, and it's going to protect our code from running with invalid data. And it's going to tell us that we have an error in the body. So it's not only doing data validation, it's also telling us exactly where the problem is. We know that in the body, inside of the price attribute in that JSON payload, the value is not a valid float. So it's telling us exactly where is the problem, which is great. Now let's actually put this back to a 9, we execute it, and it works correctly. What happens if we remove it entirely? Let's try that. Now, of course, FastAPI is also going to check that price is a field required. So let's return this price back. Now, let's say description is actually optional. So what happens if we remove it here? If we execute it, then it all works fine. Actually, let's keep returning the whole item so that we can see what happens when we execute that. So now we didn't send a description. We only sent a name and a price. But because the description has a default value of none, that is what we get here. This item is going to have a description that in this case is going to be none. So we have the response here, the description is just null. Nice. Now let's actually do something else. How do we declare nested data? Data inside of this JSON object. Let's actually say that we want to have some tags. And tags is going to be a list of strings. So this list is also imported from typing. We import list. And this is going to be by default an empty list. We're not going to modify this tag, so we can do this way. This list imported from typing is also the standard way to declare something that is a list of strings in Python. And now we can try that. Let's execute that. Let's actually reload this page here so that we get the new documentation. Now, the new documentation that is generated automatically includes these new tags that we created. And this tags is just an empty list. Or in JSON, it will be an empty array is the actual term in JSON that is equivalent. If we try to execute that, that works normally, perfect. What if we send some data? Let's actually remove the description. This is going to be sushi, I don't know. And the tags are going to be fish. And we could put more tags, but this one is enough for now. If we execute that, that works correctly, and we get the fish there in the other side. Nice. But what happens if we send invalid data inside of this list? It's not invalid data in the top level of the JSON. It's invalid data inside of a nested data structure. So let's actually send a JSON object. And the name is going to be a sneaky object. So we just execute this, and now FastAPI is going to check again and do data validation even for nested data structures. So inside of the body, inside of the tags, the item with index 1 has a problem, which is that a string type was expected. And if we go and check again what we sent, the item with index 0 is this one, and the item with index 1 is this one. So it's telling us exactly where the problem is, which is great. Now let's actually say that we want to receive not a single item, but actually items. We want to create multiple items. So we want to say items is going to be a list of items. We're going to return these items. So again, just standard Python type annotations, and this is how we declare that something is a list of items. This is standard Python, and FastAPI takes advantage of that. Now let's reload this page. Let's actually reset this, clear, cancel, and you can see that the previous example, before reloading the page, was only a JSON dictionary. Now let's actually reload it, and we can see that it's a JSON, it's now not a JSON dictionary, but a list of dictionaries. Or in JSON terms, this is a JSON array of JSON objects. That is the equivalent of a list of dictionaries. And now if we try it out, we execute it, then we get the results back because that's what we are returning. So that works as expected. And again, if we do something weird here, like fish, and now we try to send an invalid something inside of this, FastAPI is going to do data validation even for these complex nested data structures. We can declare data structures as complex as we need, and FastAPI is going to do validation of all of that, thanks to Pydantic. So let's actually see what we can do with these items. Because we are doing everything with standard type annotations, we're going to get a lot of benefits from the editor. The editor is going to be able to help us a lot. So let's say that we want to collect all the tags. We're going to say, okay, tags is going to be a set. And we're going to iterate for item in items. And then, because the editor knows that items is a list of instances of this class item, when we iterate for each one of those items, the editor is going to know that item is an instance of that class item. So we can say item dot tags, and it's going to autocomplete and tell us exactly what is it that we declare. We don't have to remember, did I say tags, did I say tag, or did I say tag names? The editor is going to tell us, and it's going to help us figuring out, like, we just said it was tags. And now we can iterate for tag in item.tags, and then we can do something with it. For example, yeah, we can take the suggestion that we are adding each one of those tags to this tags set. And now we can just simply return this tags set. Now, here's another thing. FastAPI is doing data conversion of the data that we receive, but it's also doing automatic data conversion of the data that we send. In this case, before we were just returning dictionaries, but we can return a set, which is not a JSON data type. JSON only has arrays and objects. But FastAPI is smart enough to convert this set to a simple JSON array. So we can execute that, and we can reload this page and send some data. So we're going to send sushi, and this sushi is going to have a price of 9 and a tag of fish. And we're going to send another item. Let's copy all this. And this new item is going to be, I don't know, sashimi. Although that's probably incorrect because it's also sushi. And now let's say that this time we mistakenly say that it was fish with a capital letter or something like that. We execute that, and we get the responses What did we get? Oh, we get a response that there's an error. So it was expecting a value on line 1, blah, blah, blah. This is a JSON decoding error. So FastAPI is also validating that we are actually sending valid JSON. There was an error somewhere here. What is the error? I don't even know. So, yeah, I know now. I added this last comma, and that breaks JSON. So we can execute this now, and we get the response, fish and fish. Nice. If we send the fish with lowercase, because this is a set, then Python will take care of making sure that we have only one item of each one of these tags. So we have only one single fish. But because we changed it to a capital case first letter fish, we execute that and we get the two values. So how can we fix this? We can actually trigger autocompletion inside of here and make everything lowercase. We can say tag dot lower, is it? Yes, lower. Excellent. Executed. Now let's check what just happened. I just typed tag dot and then triggered autocompletion. And the editor already knows where are the autocompletions available for strings. How does it know that? It knows that tag is a string and that it can provide autocompletion for strings because it knows that tag is a string, and it knows that because it knows that it comes from item.tags, and it knows that item.tags is a list of strings. And it knows that because each item is an instance of the class item, which comes from this list of items, which is what we declared here. So because we are using standard Python type annotations here, and standard Python type annotations in all this stuff, and here, then the editor is going to be able to help us even in these complex data, the nested data structures. And for example, it's going to prevent us from doing something like tag plus 9,000. This is not going to work. And the editor is going to tell us right away, right in the editor, even before we execute the code, hey, you cannot try to sum a string with a literal integer. So we get a bunch of the benefits from the editor because we are getting autocompletion and type checks, and we are getting data conversion and data validation and documentation automatically here. Yes, I think that's most of what I had for you. I think we can now go to the questions and see if there's anything else that we could talk about. Let me actually first show you. You can go to the documentation here at fastapi.angular.com, and you can check more examples. And there's a lot of documentation. Documentation is written as a tutorial, so you should be able to very easily understand how to do everything. There's, of course, support for headers, cookies. There's even like background tasks, lightweight background tasks. FastAPI is an async framework, so we could have done everything here as async def, and then we will be able to use await inside of it. And yeah, you can see a lot of stuff. There's also a very powerful dependency injection system that is very simple to use, but gives you a lot of flexibility for doing a lot of things. So yeah, thank you very much. I think we can go to the questions. Oh, wait, Hon, I think you're muted.
Oh, sorry. Thank you.
Yeah.
Thank you, Sebastian, for this awesome presentation. Now, let us begin the Q&A session with Sebastian and also Ruben. So if anyone have any question, please scan the QR code for the Slido to ask the question. Right. So I have the first question for Sebastian here. Right. Can you talk about the difference from Flask compared to FastAPI?
Yes, so FastAPI was actually inspired from all the learnings from very different previous frameworks that did a lot of great, they did a great job with what was available. But FastAPI takes advantage of new features of the Python language as async and await and these type annotations. You can learn a lot more about that in the documentation of FastAPI. There's a section about inspirations and alternatives, and you can see how FastAPI was inspired from. Actually, the previous thing before FastAPI that I was using was Flask with a bunch of plugins combined in very complex ways. So there's a lot of inspiration from Flask, definitely.
All right. So thank you for this answer. And I think there are some interesting questions for Ruben as well. Like, did you consider using positioner only in XML Creator, and why?
So the answer is no. So let's just sort of review for a moment that parameters typically can get either positional arguments or keyword arguments. That's like the default. And there are positional only parameters. Those are really new in Python. And you also have keyword only parameters, which are relatively new. Then you can sort of force the way that the arguments are passed. Keyword only parameters, I think, make sense. And they especially make sense if you want to have something that's like super optional, or if you want to make sure that you can use splat args and not sort of run over the default values of a regular parameter. I know that they've added positional only arguments, or positional only parameters, I should say, in the last, I want to say it's in 3.8. And to be honest, I don't quite understand the use for them. Basically, I know that they exist. I know that it was done in order to make the Python level API the same as the C level API, because you could do that in C before. But I cannot imagine a situation in which I would really want to do that. So it's sort of nice aesthetically, but I don't see why I would want that.
I see. Understand that. Right. There's another question for Sebastian. It's about like how to do a post redirect get a PRG in a fast API.
Okay. So to send a post request, then redirect something, and then make the browser do a get request, right? Yeah, you can return. There's a bunch of different responses. We didn't see anything about returning response classes directly, but we can return responses, create the response object directly and return it. And that way we can create a redirect response and return that directly to the user. But you can check that in the documentation.
Or do you want to show some live demo now?
If you want, sure. Actually, let me move it here. And share my screen again. Wait a second. Should be this one. Okay, I'm sharing my screen. Cool. So you can, let's say, app.post is what we are saying, right? Post redirect. We're going to say define redirect route. Yeah, that works. And we can return, no, this is not what I want, from fast API dot responses redirect response. Oops, what is this double thingy? No. It's imported from Started and from fast API. Import. Yeah. I don't know why is it doing something weird here. Okay, good. And now we can return a redirect response that goes to just slash. And now we can reload that here. And if we try to execute it here, this would say, why method not allowed? Because by default, this is going to redirect using a status code that preserves the same HTTP method. So we can redirect with 302. And now reload this thing. And now try it out and execute it. And this is redirecting to the hello world thing that we are. So we are getting the response of this root thingy. We can, I don't think there's a simple way to try it out, like without writing a form to send the data, but yeah, like I think you can see how this is actually redirecting from the post that we sent and getting the response from the root path operation. I guess that answers the question. Wait, how you're muted?
Sorry. Yeah, it's pretty clear. So I have another question here for Ruben, like how to make the function decorator and chain them together. Would be great. Would be great that if you have some live demo.
I don't have a demo per se, but I can probably throw something together now that Sebastian has put me on the spot and maybe like feel guilty for not being able to code. Let's see this. Let's see if I can share my screen and play with that a little bit. Let's just get one that. So the question is, how can we like chain the decorators together? Whoa, let's not do that. Oh, I'm sharing the wrong one. Let's not share that screen. Sorry, folks. Let's share the other screen. That's funny, I thought. All right, let's just do this on a particular window. There we go. Okay. Ta-da! Now we have. So basically, the question was chaining the decorators together. Just to double check, do I remember the question? Han, sorry.
So the question is how to make the function decorators and chain them together.
So I mean, there are a few different ways that I can interpret that question. The most common one is that you're going to want to have two decorators on one function. So let's just do here, def add of A and B, and we'll return A plus B. So let's say I want to have here, you know what? Watch this. Watch this. Let's actually use our once paren decorator. So I'm going to use this once again. All right. So I'm going to use this here. And so I can, and I'm going to put a little bit of debugging code in. I'm going to say print now running once per n on n, right? And then we're going to say here print now running. Well, that we don't actually need anything more than that. And then we'll say here actually do this now running once per n wrapper. Okay, so if I run things now, right, and let's actually just copy that before, and I will get to the chaining in just a moment. Right, so now if we run it, you can see that we're running once per n of 0, once per n for 0. We're running the outer function there. I'm ignoring the middle one for now. And then we're running each of the inner functions, the wrapper one, just fine. The thing is, what if I want to have an additional decorator there? And this is not an uncommon thing that you'll see, especially in various frameworks. So what happens then? Well, we just define another one. So I'm going to say here def, let's just call it, loud deco. And here I'm just going to say func. And I'm going to say here def wrapper, splat args, and we'll say here print. I'm going to do the same sort of thing, print now running loud deco. All right, and then what I'm going to do here is I'm going to say now running loud deco wrapper. And if I then say value equals func of args, and then return value, and then we'll say return wrapper here. So I can use this, right? And this will be fine. But what's going to happen when I say loud deco here? And what's going to say when I say loud deco here? Well, let's look at two different things. First of all, let's look at the order in which each of these things happens. So you can see, so what I do, I said at loud deco and then at once per n. But we see actually that it's running in the opposite direction. That first once per n is running, and then loud deco is running. And that aligns with what we expect, because it's always going to be this decorator running first. And then once that is all decorated, then loud deco is handed it. Now remember that a decorator, basically, it's sort of like saying add equals once per n of, well, 0, and then add. And then we're doing that again. Then what we're going to do is we're going to say add equals loud deco of add. So we're actually assigned to add twice here. So at the end of the day, the add you have here is the result of loud deco, which has a local variable, which points back to the original add, which points back to this, which points back to the original one. So you can do this, and it's not unusual to do it, but once you start thinking about it a little too hard, it gets a little confusing. But certainly you can do this. One other thing I just want to point out, which is whereas once per n and then loud deco read in that order, it's actually done in the opposite order when we run the functions, because we're sort of going from the outside in now instead of the inside out.
Right. Okay. Yep.
I can give you a headache medicine if this is too much for now.
Yeah, I hope it is clear for the attendee. Yeah, please type your question in Slido if you have an additional extra question to ask Ruben. Right. So right now we have one more question. Yeah. So this question is for Sebastian. So this is how to authenticate the static routes in Fast API. Sebastian,
Wait,
you are
I'm muted.
Yeah,
Now it's
you're
my turn to be muted.
Yeah, everyone.
For static routes will be like for static file, like front-end files, or just how to authenticate routes in general. Wait,
I'm not very sure. Yeah, I'm not very sure. Yeah, what he's
let's.
expecting.
I'm not sure. Like I'm not sure what's the question, but I can show you. Let's see, just simply how to authenticate route simply with FastAPI. So we can import from fastapi.security import. Let's do a very simple thing, and we're just gonna do an HTTP bearer token. And we're gonna say that post items is gonna receive credentials. So this is gonna be, we just, now we're gonna use the dependency injection system that I was talking about. So we're gonna say credentials is equal to also, wait, let me just import it first. No, this is HTTP authorization credentials. Yes. Thing. I'm adding the type here just so that we can get auto completion internally. So now I say this is equal to depends, and this depends is important from FastAPI here. And now I'm saying this is equal to depends, and I'm going to call this with an HTTP bearer object. So I'm going to create this here. HTTP bearer equals to HTTP bearer object. I create one just because this is going to be included with the automatic interactive documentation. So now I can put this here. Actually, let me format this so that we can see it more easily. And now I can say if credentials, this is going to be a string, is equal to, let's say, just secret. This is actually badly done, but just for the sake of showing it quickly. If this is not, if the credentials that we received in a bearer token are not the key secret, we can raise an HTTP exception, and this is gonna be imported from FastAPI, HTTP exception. Saying the status code, this is like, I don't know, 403. Actually, let's use this example. Not authorized. Good. We save it. And if we reload the interactive automatic documentation here, now we get this button here that allows us to authorize the requests. And we can say, ASDF, this is incorrect because we say that we were going to check with the value secret. But we try to authorize with that, and we try to send a request here, and we execute that, and we get the response, hey, this is not authorized. Now, if we remove that bearer token, and we just try to do it like that, we also get an error saying that this is not authenticated. And of course, we shouldn't do this. We should instead import secrets, and instead of comparing this thing like this, we should do secrets.compare digest, and then put this internally just to be safer. And we shouldn't put this secret literally here. We will probably read it from an environment variable or something like that. But for the sake of argument, this is simple enough to see how it will work and how it's integrated with the OpenAPI of documentation. In this case, we are just using an HTTP bearer header. So this is sending a header with a bearer token, for example. But the same way we could use all the integrated OAuth 2 authentication methods. Yeah, that's it.
Right. Yeah. Thank you, Sebastian. We actually have a very interesting question for you from the attendee. Like, what has been the best thing you experienced after creating such a popular framework like Fast API? And
And
I do
then,
not know how to read this. Yeah, but I think you know
saludos
this.
desde Japón.
What does
Because
that
this
mean?
person speaks Spanish. That means saying hi from Japan.
Oh, all right.
Saludos
Interesting.
desde Alemania, which
Saludos,
means
yep.
hi from Germany. So
Hi from
what is the best thing that I have experienced after? I don't know, like they're having a lot of very nice experiences and surprises that I didn't expect. FastAPI is being used by a lot of things in a lot of places. It's being used to process simulated galaxies. It's being used to analyze telescope data. It's being used to handle the incidents, the incident response at Netflix, to handle APIs at Microsoft. And for example, recently with all the COVID, there were a lot of COVID trackers and COVID APIs and COVID systems trying to help manage the data for COVID, built with FastAPI that allow building those services faster because it's just fast to build. So I think there's a lot of things that are very exciting news and that are very exciting things that happen with these tools.
Right. Well, actually, I would like to ask the same question to Ruben. Like, what is your best experience after like you published the book Python Workout and after you launched your learning institution? Yeah.
Look, I think that at the end of the day, it's just an amazing feeling. Like one of the things I love about doing training is that I'm basically helping people improve their careers. And so to hear from people around the world telling me, thanks to your book, I was able to understand things better and do my job better, or thanks to your book, thanks to your courses, I was able to get a job, right? Like it doesn't get better than that. It's like the best feeling in the world. I mean, back before Corona times when I would go on site to companies, and I would do repeated training on site, sometimes people would come up to me in the cafeteria, like during lunch, and say, oh, we just use what you did. It's the best. It's the best. So I enjoy hearing from people. It's also like hearing people I've never met, knowing that they're using what I taught them, and using to get ahead. Anyway, I just can't get enough of that. It's a real ego boost.
Is your book going to publish in Japan, like Python Workout or Pandas
I believe so. I know that they were talking about a bunch of different translations. I know that it's going to be translated into both simplified and traditional Chinese and into Korean. So I assume that there's also a plan to translate to Japanese, but I do not remember what Manning told me. But let's hope yes.
Looking forward. If you are, please share with us if your book is translated into Japanese language. Right.
I would be delighted, absolutely.
So to the attendees, if you have any other questions, yeah, please share with us through the Slido app. Right. Yeah, I think that's all for the question part. Yeah, and yeah. Right. Last but not least, like I would like to ask Sebastian and also Ruben, like, what is a message that you want to share with our attendees before we ending this event?
I will go further. I will say just like if you're interested in FastAPI, go check it out. Go check documentation. And something that will be very helpful if you want to get involved is translating the documentation. There's a team of people that have been working a lot translating the documentation to Japanese, and I don't know how they can do so much work, but there's still, of course, a lot of documentation that could be translated as well. And this could help the other, like other fellow developers in Japan to be able to use these tools more easily. So my recommendation, the thing that I want to encourage you to is to go check the documentation, see if you like it, if you're interested, and if you can get involved and help your fellow developers, that will be awesome.
Right. So how about you, Ruben?
People are always asking me, like, what technology should I know, or what do I need to know, like to know the next big thing. And the most important thing you can know is how to learn. like how to learn new things. Our industry moves all the time. And if you only know a certain set of things and then you're like, this is it, I'm never going to do anything else, you're going to be in big trouble. So getting comfortable learning, figuring out the best way that you can do that, and just keep doing it again and again and again in your personal life, although you might not have a personal life if you do it too much, in your work life, really, and try to work with people who encourage you to learn things and do new things. I was once at a company about to give a course, and the head of HR got up and said, we're giving you this course to do your jobs better, also because we know that you will eventually leave us, and we want you to be better prepared for your next job. And I thought that was very kind and generous and realistic. And so have that attitude. What can you do to get to your next thing, and enjoy it while you're learning it? Because for crying out loud, you should. There's a lot of fun stuff in the computer industry, and suffering shouldn't have to happen too much.
Yes, I agree with that. And actually, this is also my first time like being a moderator in a virtual event. And to the attendees, if you are interested to know more about Fast API, or if you would like to contribute to translate the documentation, please visit the Fast API documentation website. So, right, we'd like to say a big thanks to Ruben and Sebastian for taking time to share their knowledge and a very interesting presentation to attendees. So, and also thank you to all the audience for your active participation. Right. I would like to announce that the 5th event of the Global Dev Study Series will be held on 27th of July, 8:30 p.m. until 10:30 p.m. Japan time. So we will have Lucas Langa, the core developer of Python and the release manager of Python 3.8 and 3.9, Luciano Ramajo, the author of Fluent Python, and Pat Fiervo, the author of Robust Python. So you can register for the event from the Fogwell Campus webpage. So once again, thank you everyone, and we hope to see everyone again in our next event. Thank you.
Thank you very much for the invitation. Bye.
Thank you.
Great. Bye, folks.